Hi friends, welcome to my another video. Today in this video, I will discuss about the SMDB designing. This is the part 7 video in series of designing of G+4 building as per DEWA regulation. In part 6 video, I also discuss SMDB designing, but in that video, I covered what is connected load, total connected load, maximum demand load and demand factor. I deeply cover these 3 points. Apart from that, I discuss about the DEWA regulation related to SMDB in very deep. Apart from that, I discuss about the DEWA load schedule format for SMDB and for MDB in very deep. In this video, we will design and calculate the main breaker rating of SMDB. Main breaker. We will calculate the incomer cable sizing for SMDB. We will calculate the outgoing breaker size and we will calculate the outgoing cable size. So in this video, our focus will be to know how to calculate the main breaker size for SMDB, how to calculate the main incomer cable size for SMDB, how to calculate the outgoing breaker size for SMDB, and how to calculate the outgoing cable for the SMDB. Apart from that, we will try to prepare one load schedule for SMDB as per DEWA regulation. So I recommend you to watch part 6 video and then come to part 7 video, as both part 6 and part 7 video is related to SMDB designing. I will provide the part 6 video link in the description box. So let's begin this video. As in the previous part video, we already calculated the total load for 1 BHK flat, 2 BHK flat and for the common area power dB and common area light dB. As I told in my previous video, 1 BHK flats are typical, so the load also of every 1 BHK flat is same. Okay, so we know the load of each flat and we know the load of common area light dB and common area power dB, which I wrote here in the SLD of the SMDB. Here DB101 has the load of 14.9 kilowatt. Same way for DB102, 103, 105, 106 and 107, because these are 1 BHK flat and typical to each other. DB104 is a 2 BHK flat and the load is 18.75 kilowatt. Here there is two other DB, DBL01, that is the DB light DB for the common area, and the load on that DB is 3.35 kilowatt and the load on the power DB is 6.64 kilowatt. Our intention is to calculate the breaker rating first for each outgoing breakers. Then our intention will be to calculate the cable size for each outgoing load of the SMDB. Then we will calculate the breaker rating and the cable size for the SMDB. So let's start this one. Here I already wrote DB101, 102, 103, 105, 106 and 107 are typical flats and it is 1 BHK flat. And we know the load on that DB is 14.9 kilowatt. Okay. So P, we know by three-phase formula, power is equal to √3 into V into I into cos phi. So we will calculate the I. I will be equal to P by √3 into V into cos phi. We know the power, the load on the DB. So it is 14.9 kilowatt. So in order to convert into the watt, I wrote 1000 divided by √3, that is 1.732 into voltage, that is 415 volt, and power factor I consider 0.8. I will tell you why I consider 0.8, because we will design one capacitor bank also, and in this capacitor bank micrological controller we will set the power factor minimum to be 0.8. That will be in upcoming videos. So once we will calculate this numeric value, we will come to the current on the DB is 25.6 ampere. So for the breaker rating, we have to consider the safety factor. So we can take the safety factor from 1.25 to 1.5. So the breaker rating will be 1.25 times of the current on the DB. Current on the DB I calculated 25.6. So the breaker rating will be I breaker is equal to 25.6 into 1.5, that is equal to 32.06. So which one is the nearest standard breaker size? So the nearest available standard breaker size is 40 ampere. So for DB101, 102, 103, 105, 106 and 107, the breaker size will be 40 ampere. So we will write here the breaker size here will be 40 ampere triple pole. Okay, 40 ampere triple pole. We will write here 40 ampere triple pole 40 ampere triple pole, 40 ampere triple pole, 40 ampere triple pole. Okay, now we have to calculate the cable size for that dBs. So what we will do, the cable size will be 1.25 times of breaker rating. Okay, so what is the breaker rating? It is 40 ampere. So we will write 1.25 times of calculated breaker rating. Okay, calculated breaker rating is this one, 32. So we will write here 32. So it came as 40 ampere. So we have to select a cable which should have a cable ampacity, current ampacity of 40 ampere. When we will refer to DEWA load schedule, then we will find that for 10 square mm, the cable ampacity is 50 ampere. Okay, so we can choose in here also, it is for the multi-core cable and it is for the PVC core, PVC cable, and this is XLPE cable. For 40 ampere current, the cable size should be 10 square mm, as the 10 square mm cable current ampacity is 40 ampere. So what we will do, we will write here our required current on the cable is 40 ampere. So after referring the DEWA load DEWA regulation, we came to know that the 10 square mm XLPE multi-core cable plus 10 square mm ECC cable will be enough for this load, that is 14.9 kilowatt. So we calculated the breaker rating of the dB and the cable size for the dB. Hope you are clear with this point. So we will write here what is the cable size here. 10 square mm XLPE CUSWA cable plus 1 core 10 square mm ECC cable. So we will write here, 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 here and here. Now we calculated the breaker rating for 1 BHK flat dB and the cable size for 1 BHK flat dB. Now let us calculate the breaker rating for the 2 BHK flat dB. As we know, the load on the 2 BHK flat is 18.78 kilowatt. Okay, so the load P is equal to 18.75 kilowatt. As per the three-phase formula, P is equal to root 3 into V into I into cos phi. So I is equal to P by root 3 into V into cos phi. So P we know 18.75 in kilowatt. So to change in the watt, I multiply it with 1000 divided by root 3, that is 1.73, into voltage, that is 415 volt, into power factor. Once we will calculate this one, we will get the value of 32.2522 ampere. As I told you, the breaker rating will be 1.25 times of the current on dB. So current on dB is 32.2 ampere. So breaker rating will be 32.22 ampere into 1.25, that is equal to 40.08 ampere. So the nearest standard cable size is 40 ampere, or we can take 50 ampere also, but it is just a slight increase, so we can take 40 ampere. Okay, as we already took 1.25 safety factor. Now for the cable ampacity, we have to check that our calculated cable rating is 40.08. So the cable we have to select which can carry a current of 1.25 of the calculated breaker rating. So 1.25 into 40 ampere, then it came 50 ampere. As per the DEWA regulation, we can see here that 50 ampere current can be carried by 10 square mm of cable. So we will choose a cable of 10 square mm multi-core cable with 10 square mm ECC cable. So we can write here the breaker size will be 40 ampere, or you can write 50 ampere. There is no problem in that. And the cable size will be 10 square mm XLPE cable plus 1 core 10 square mm ECC cable. Hope you are clear till here. Now we calculated the breaker rating for all flats dB. Okay. Now we will go to calculate the breaker rating and the cable size for the light dB of common area. So here I wrote dBL01 common area light dB. In same way, we know the load on the dB is 3.35 kilowatt. So P is equal to root 3 into V into I into cos phi. The current on the dB, we calculated 5.75 ampere. The breaker rating will be 1.25 of the calculated breaker current on the dB. So 5.75 into 1.25, it is came as 7.18 ampere. Okay, so the nearest breaker rating is 10 ampere or 16 ampere. Okay, we will choose 16 ampere, and in the MCCB we will have the option to select that 16 ampere nominal breaker rating to 10 ampere as a rated by adjusting the dial. Okay, so we will choose 16 ampere breaker rating and we will adjust it to 10 ampere, and in future if the load increase on that dB, then we can again adjust the dial to 16 ampere. This is the benefit of going for MCCB. which having a selection range dial for the nominal current to rated current. Okay. So after calculating the current rating for the cable, we got the value of 20 ampere. As per DEWA regulation, we need 4 square mm cable to carry a current of 20 ampere. So I choose 4 square mm cable. It could be PVC and XLPE, but I will choose XLPE cable because as per our designing, the XLPE cable is allowed for DB. So I choose XLPE cable 4 square mm, and 1 core ECC cable also will be 4 square mm. Hope you are clear with this point. Now, so I will write here the breaker size is 16 ampere triple pole, and the cable size is 4 square mm XLPE and plus 1 core 4 square mm ECC cable. Now we will calculate the cable size and the breaker size for DBP01, which is feeding the common area power load. So here I mentioned DBP1 common area power load DB. In same way, when we will calculate the current on the DB, we will get the current rating as 10.99 ampere. The breaker rating will be 10.99 into 1.25, that is equal to 13 ampere. The next standard size is 20 ampere. So breaker size will be 20 ampere. Now the cable ampacity will be 1.25 times of the breaker rating. So it came as 25 ampere. If we will refer the DEWA load schedule, then it is between this range 20 to 25. So we cannot go for the lower one, we can go for the higher one. So 6 square mm cable is capable to carry 30 ampere of current. Okay. So we will write here the XLPE 6 square mm cable and 6 square mm ECC cable. So we can write here in our SLD, this will be 20 ampere triple pole and the cable size will be 25 square mm XLPE cable plus 1 core 6 square mm XLPE cable. Hope you are clear now. After calculating the outgoing breaker rating and the outgoing load cable size, let us calculate the total load on the SMDB. What would be the total load on SMDB? The sum of all connected load on SMDB will be the total connected load on SMDB. So we will add all this load to get the total connected load on SMDB, and we will write here the total connected load on SMDB will be the load on DB101, load on DB102, load on DB103, load on DB104, DB105, 106, 107, and load on DBL1 and load on DBP1. So the load on DB101 is 14.9, for DB102 14.9, for DB103 14.9. The load on DB104 is 18.75. The load on DB105 is 14.9. The load on DB106 is 14.9. The load on DB107 is 14.9. The load on DBL1 is 3.3 kilowatt and the load on P1DB is 6.4 kilowatt. If we will add this load, we will come to a value of 118.08 kilowatt. So this is the total 118.08 is the total connected load with this SMDB. Hope you are clear so far. Okay. Now this will be the total connected load. So in order to get the current on SMDB, we have to use this formula, three-phase formula. Then I SMDB will be the load on SMDB into 1000 watt divided by √3 into V into cos phi. After calculating this, we will get a value of 205.3 ampere. So the current on SMDB is 205.3 ampere. As I told you during discussing DB breaker sizing, the breaker size for SMDB will be 1.25 times of the current on SMDB. So the total current, the breaker rating of the SMDB will be 256.3 ampere. So the next standard size cable is 300 ampere. Okay, because 250 ampere will be lesser than 256 calculated rating. So we will go for 300 ampere breaker rating of the SMDB, which will be the incomer breaker rating of SMDB. As per the cable, now we have to select the cable which should have the current ampacity more than 1.25 times of the calculated breaker rating. So 1.25 times of the calculated breaker rating, then it came as 320 ampere. If we will refer DEWA load schedule, then we will see that 320 ampere is coming coming in between 300 and 350. So the breaker size, the cable size will be 240 square mm. So I wrote here the cable size should be 240 square mm with the ECC size of 120 square mm. Hope you are clear now. So what we conclude from this discussion, that the breaker rating will be 300 ampere for the SMDB main breaker rating, and the cable size should be 240 square mm. So we will update in the SLD. Here we can write that 300 ampere triple pole breaker rating will be the incomer of the SMDB, and the cable size should be 240 square mm 4 core 240 square mm XLPE cable plus 1 core 120 square mm ECC cable. Now so far we have calculated the main incomer breaker rating, main incomer cable rating, and all outgoing breaker and cable rating for this particular SMDB. But as I told in my part 6 video of SMDB designing, that we have to calculate the maximum demand load also, apart from the total connected load. So we will calculate the maximum demand load for that SMDB also. Okay. And in very deep in part 6 video, I explained what is the maximum demand load and what is the importance of maximum demand load. Okay. I consider that for the flat DB, maximum 70% load will run at a time. So the demand factor for this flat DB is 0.7, or we can say 70%. So I wrote demand factor I took as 70% or 0.7, anything you can say. DB for 101 flat, DB 70% of 102 flat, 70% of 103 flat, 104 flat, 70% of 105 flat, 70% of 106 flat, and 70% of 107 flat. DBL1 and DBP1, which is feeding the common area, I consider the maximum load on that DB is 85% of its connected load. So here I took the demand factor as 0.85. You can choose here 90% also, because there is no straight formula to calculate the maximum demand, and we can only assume by considering its load nature. So I took it as 85%. So when we will calculate the numeric value, we got the total maximum load on the SMDB will be 83.99 kilowatt. So here in the SLD, we will update this one. The maximum demand load is 83.99 kilowatt. 83.9999 kilowatt. I hope now you are very clear with the SMDB's designing. Same thing we will tabulate in the DEWA load schedule format for SMDB, and we will finalize this video after that. Now, as we prepare the SLD for this SMDB, okay, I calculated the main breaker rating of SMDB, the main cable size of SMDB, the outgoing load, cable size, and the breaker size. We have to formulate this one in a load schedule. So how we will do, we will learn here. Here first we will do the outgoing, then we will go for the incoming. So what are the DBs available? DB101, DB102, DB103, DB104, DB105, 106, 7, and DBL1 and DBP1. So here in the outgoing, what are the DBs available? We have to write it here. Okay. So we will write DB101, 102, 103, 104, 105, 106, 107, DBL1, DBP1. And we consider one space spare here and one space we will consider. Okay. So all the breakers are triple pole. You can see all DBs are 3 phase. So all the breaker will be triple pole. So we will write here the breaker size will be, the breaker pole will be 3 pole breaker. Now for the outgoing, we have all MCCBs. Okay. There is no isolator. So here there is a 2 category for the breakers. One is isolator and other category is MCCB/ACB. But here we don't have any air circuit breaker, only MCCB we have. So I deleted air circuit breaker. Okay. And we have for DB101 40 ampere breakers. So here I will write 40 ampere for all the 1 BHK flat, and for 2 BHK flat it's also 40 ampere. Here in DBL1 the breaker rating is 16 ampere and DBP1 the breaker rating is 20 ampere. So I will write accordingly. For DBL1 I will write the MCCB rating as 16 ampere and DBP1 as 20 ampere. So we will write here. Okay. Here for DBP1 the breaker rating will be 20 ampere. Spare I consider as a 25 ampere breaker for future load. Hope you are clear now. When I was discussing the SMDB designing in part 6 video, I told you that the prospective short circuit fault current is a very vast topic, and I have already one video on the prospective short circuit fault current calculation. at every stage of electrical installation, like at transformer level, at MDB level, at SMDB level, at final distribution board level, and at the load level. This is very deep topic. I will provide the link in the description box. Watch that video. But to complete this topic, I will tell you one normal thing, one general thing, that for the DB level, the prospective short circuit fault current is considered as 25 kilo ampere. But it is not correct in all the situation. We have to calculate it and then we have to write it. So watch that video to know how to calculate the prospective fault current. But for time being, I took the prospective fault current as 25 kilo ampere. Now, all the wires are 4-core wires because all DBs are 3-phase DB. So here the cores of the wire will be 4 cores. Okay, all are 4 cores. Now, type. What are the type of the wire? It is type of the cable. It is PVC, XLPE, SWA wire. It's not a single core. It is 4-core XLPE, PVC, copper core, and SWA armored cable. So we will write that one. XLPE, SWA, PVC cable. What is the size of the cable? Here you can see that DB101 has 16 square mm wire, DB102 16, DB103 16, DB104 16, 5, DB105 16, DB106 16, DB107 16, but DBL1 has 4 square mm and DBP1 has 6 square mm. So we will write the cable size here. Okay. Just I am looking at the SLD and I am writing the things. Okay. Now the ECC wire, I already prepared one video how to select the ECC wire depending on the phase conductor. So as it is less than 16, so for less than 16, the ECC wire and the phase wire are same. So for each 10 square mm wire, the ECC wire will be also 10 square mm. The length of the cable. During discussing the SMDB designing, I told you we have to measure the flat DB location from the SMDB location. Physical length we have to measure and we have to write here. Just for an example, I consider that the flat 1 is 20 meter far, flat 2 is 25 meter in same way, and this 2 dB inside the electrical room and the SMDB is also inside the electrical room. So I consider that the total length between this DBL1 and SMDB is 10 meter and DBP1 and SMDB is 10 meter. Now, here it is very important, connected load. In my previous video, I already discussed that the 2 BHK, I already prepared the 2 BHK load schedule, okay, 1 BHK load schedule. I prepared the common area light DB load schedule and the common area power load schedule. Okay. Now we are in the phase of calculating the SMDB. We are in the phase of preparing the SMDB load schedule. So here what we will do, this is for DB101. DB101 is a 1 BHK DB. So all DB is typical. So here you can see that the total load per phase is mentioned here, 4,955, 5,000 and 4,974. So we will copy this load and we will paste here. So what we will do, we will formulate this SMDB load schedule with our DB's load schedule. So here you can see DB101, we will write here equal, and I will go to first 1 BHK SMDB and I will select the R phase load and I will press enter. So here the value came and it is 4,955. But here what I will do, I need this load in kilowatts. So I will divide it by 1000. I will get the value as 4.96. In same way for Y phase, I will press equal. I will go to 1 BHK load schedule. I will select this load on Y phase. I will press enter. And again I will select it and I will divide it by 1000. I will get the value of Y phase. In same way for B phase, I will press equal. I will go to 1 BHK flat DB. I will select the load on B phase on that DB. I will press enter. Again, I will check the formula and I will divide it by 1000 and I will get the value in kilowatt for the B phase. Okay, the hash is coming because the space I put less. For another one I will show you. This is for DB 102. So 102 is also same 1 BHK DB. So I will put here equal sign. Then I will go to 1 BHK flat. Then I will select the R phase load and I will press enter. But here it came in kilowatt. Watt. So I will divide it by 1000 and it came in kilowatt. In same way I will repeat it for B phase. I will divide it by 1000. In same way I will repeat it for blue phase. I will select the blue phase load. I will press enter. I will divide it by 1000. Hope you are clear now. Now same way I will do for all 1 BHK flat. Let me do for 2 BHK flat. Here the 2 BHK flat is DB104. Okay, DB104. Here the R phase, so I will press equal. I will go this time to 2 BHK flat DB. I will select R phase and I will enter. Here the R phase load came, but it is in the watt, so I will divide it by 1000. In same way I will go to, I will zoom it so better you will see that one. I will go to B phase. I will write equal. I will go to 2 BHK flat. I will select the B phase load. I will press enter. And I will divide it by 1000 to get the load in kilowatt. In same way for B phase, I will press enter. I will go to 2 BHK flat. I will go to blue phase for 2 BHK flat. I will press enter. I will divide it by 1000. Okay. Hope you are got all the points. So in same way, I will fill for all the dBs and we will get the load per phase for all the dBs. So I will pause this video and I will complete it and then come back. Now I have did the same thing for all flats. Okay. Now we will do the thing for dBl1 and dBp1. So what I will do, I will first increase the cell size. Now what I will do, I will press equal. I will go this time to the dBl1. I will press here. I will press the total load on R phase. I will press enter. I will select it and I will divide it by 1000. Okay. Again, I will show you. I will press equal. I will go to light dB. I will select the total load on Y phase and I will press enter. After that, I will divide it by 1000. In same way for B phase, let me first zoom this load schedule. Okay. I will press equal. I will go to light dB. I will select this time to B phase load. I will press enter. Here you see the load came in watt. I will divide it by 1000 to get the load in kilowatt. Same I will repeat for dBp1. I will press equal. I will go this time to dBp1. I will select the R phase load. I will press enter. I will divide it by 1000 and enter. Let me zoom it also this one. In same way for Y phase, I will press equal. I will go to dBp1. I will select Y phase load and I will divide it by 1000. In same way for B phase, I will go to dBp1. I will select B phase load. I will press enter. I will divide it by 1000. So I got all the R phase load, Y phase load and B phase load for each dB. In order to get the total connected load, what we will do, we will sum it. The R phase load, Y phase load and B phase load. Very clear. So I will write sum and this 2, this 3. So this is the sum of this, the total load on dB101. The same formula I will apply for all other phases. So the load came for all dBs. Here you can see that the load on the flat dB 1 BHK is 14.93 kilowatt. For the 2 BHK is 18.73. For the light dB is 3.35 and for the power dB common area 6.40. Here we have to calculate the total load on R phase. So I will sum up here, sum the total load on R phase and I will press enter. Okay, in same way I will calculate the sum of all load on Y phase. So I will press here. Again I will calculate the total load on Y phase. So I will sum up all the loads on Y phase and I will sum up here. So this is the total load on Y phase, R phase. This is the total load on Y phase. This is the total load on B phase. Now, in order to get the total load connected on this SMDB, we have to sum the load connected on R phase, load connected on Y phase, and load connected on B phase. So we will write here equal to this one plus this one plus this one and enter. So we will get the total connected load, that is 118.08 kilowatt. Okay. Now we will move to max demand load or operational load. So what we will do here, during discussing the SMDB designing, I told you for dB we will consider 0.7 as a maximum demand factor. So it will be 70% of the total connected load. So it will come as 10.45 kilowatt. So the total connected load on dB101 is 14.93 kilowatt, but the maximum demand load on dB101 is 10.45 kilowatt. Meaning at any instant of time, the maximum load on the dB101 will go maximum to 10.45 kilowatt. Okay. And I will drag this formula to all flat dB, because for all flat dB I took 70% as a demand factor. Okay, 0.7 as a demand factor. For the common area light dB, I told you we will take the demand factor as 0.85. You can take it 90% also, as there is no straightforward formula, and we will calculate it with respect to total connected load. So it came as 2.85 kilowatt. What does it mean? It means that dBl1 has a total connected load of 3.35 kilowatt, but any instant of time in a day or in a month or in a year, that dB load should not reach more than 2.85 kilowatt. So when suppose dB has 10 loads, all the loads will not be operational at a time. Maybe 7 or 8 load will be operational, and when other 2 load will on, then the load which was operational will shut down. So in that way we can say that the all total connected load will not be operational at a time. So here we consider that the 85% load of the total connected load can be operational at a time. So we took the maximum demand factor as 0.85. This I already explained in very deep in part 6 video of SMDB designing. Same formula I used for the dBp1, where I took that the 85% of the total connected load can be come into the dB at a time. Okay. Now we got the maximum demand load. We got the total connected load per dB. Okay. Now we will sum here to get the maximum demand load. Maximum demand load for full SMDB. What does it mean? This is the maximum demand load for dB101. This is the maximum demand load for dB102. In same way, these are the maximum demand load with respect to dB. If we will sum up all these maximum demand load, then we will get a value 84.12, which is the maximum demand load for this SMDB L1. Hope you are clear now. Okay. Now, what we will do, we will calculate the overall demand factor of that SMDB. This demand factor 0.7 I consider for dB101. This demand factor for that is 0.85 I consider for dBl1, but I don't know the total demand factor for the SMDB. So how we will calculate? We will divide this maximum demand load by total connected load, which I already explained in deep in part 6 video. So we will equal, let me make it black. What I did, I divided maximum demand load to total connected load. Then I got the value of 0.71. Okay, this is the maximum demand factor for this SMDB. Hope you are clear. You are not confused that this 0.7 is what and this 0.71 is what. This 0.7 is the maximum demand factor for this dB, and this 0.71 is the maximum demand for overall SMDB L1. Hope you are clear now. Now we have done with the SMDB load schedule formation. Here we have one column, proposed type or number of kWh meter, one phase kWh meter, three phase kWh meter, and LVHV CT current transformer. For each flat we need one kWh meter, because this flat is owned by one person, this flat is owned by another person, so they want to know how much electricity they consume. So for each flat there will be one kWh meter. So there is 7 flats, so there will be 7 kWh meter. But for LDB1 and LDBL1 and DBP1, it is a common load, so there is no need of kWh meter separate for DBL1 and DBP1, because there will be overall meter in the building, and that consumption will be considered in that kWh meter. So here we don't need any kWh meter, and the total kWh meter will be 7 for related to this SMDB. Hope you are clear now. So far we have completed the outgoing sections. Now let us move to the incoming section. Here the breaker will be 3-pole or 4-pole breaker, and the breaker in the SMDB either will be isolator or will be MCC. But as per DEWA regulation, the upstream panel should have the breaker and the downstream panel should have the isolator. For example, I'm telling you, when I was preparing the load schedule for DB flats, here you can see, then I wrote here isolator. Okay, but when I was preparing the load schedule for SMDB, then I wrote here it is a breaker, MCCB, for the same DB. Okay. And for this SMDB, the upstream panel is MDB and the downstream panel itself is the SMDB. So here the downstream panel is SMDB, so we can put the isolator, not MCCB breaker. But when we will design the MDB, then we will write the breaker for this SMDB will be the MCCB type, not isolator. Hope you are clear. So when we calculated the main incomer breaker rating for SMDB, we came to know that it is 300 ampere. So I wrote isolator 300 as I'm preparing the SMDB. When I will prepare the MDB load schedule, then I will write 300, but I will write in the MCCB section. The fault level at the SMDB side is considered as 35 kiloampere. But to know actually how to calculate, watch that video for the maximum prospective short circuit fault current. Okay, link will be in the description. The number of core, it will be 4-core cable, because the SMDB itself is a three-phase SMDB. So I wrote 4-core. The cable size, the cable type will be XLPE SWA/PVC, and you can write here CU also /CU. The cable size, when we calculated, it was 4-core 240 square mm. So I wrote here cable size is 240 square mm. ECC size will be 120 square mm. So I wrote here 120 square mm. The length of the cable, this length of the cable is from SMDB to MDB. It means when we will physically measure this one, then we will get this value. For time being, I wrote 80 meter. Okay. Now we know that total connected load on R phase on SMDB is 39.49 kilowatt. The total connected load on Y phase on the SMDB is 39.36, and the total connected load on B phase on SMDB is 39.37. So same thing I copy here: 39.34, 39.36, and 39.37. Hope you are clear now. The total connected load on the MDB is how much? 118.08 kilowatt. So we will write here the same thing: 118.08 kilowatt. What is the demand load? Maximum demand load for the MDB is 84.12. So we will write here the same 84.12. Okay, here we will write 84.12. Okay, now this is all about the SMDB load schedule. Now, apart from that, I wrote here the project name. It is just a sample I'm making, but I wrote the project name as G+4 building. The panel name is SMDB L1, fed from MDB. Owner name, you can write whoever be the owner. Consultant, whoever be the consultant, write the consultant name. Area where this project is, in Dubai, where it is. Plot number, what is the plot number of this project, and the panel of the location. Panel of the location here will be first floor electrical room. Okay, this is all about the SMDB designing. I hope I cover every topic, and I make this video in a simple language, and I explain you in a simple way so everyone can understand this one. Okay, I hope you find this video informative. If you really enjoyed this video, then please like this video and subscribe to my channel. My 70% of the viewers watching my videos but not subscribing my channel. So it is my humble request to subscribe my channel, and more important, share this video with your electrical friends so my reach will be with more and more electrical professionals and engineers. And kindly press the bell icon for future videos update. Kindly react in the comment section also, so I will get motivation and I will know your doubts, and I will try to clear in the comment box itself. And if required any separate video to clear that doubt, I will prepare one separate video for that. So kindly react in the comment section. We will meet in part 8 video. Till then, take care, keep learning, and bye-bye. Thank you so much.